So to find out whether something makes a group, we have to have these properties be satisfied. It's got to have closure, which means that if you take any two elements and you perform the operation, you should get another element that's within the group. And that's pretty clear with integers, right? If you take an integer, multiply it by another integer, you're going to get an integer. You're not going to get an irrational number or something like that. So this does have closure, because you can multiply numbers within a set of integers, and you'll always get an integer out. You won't, two integers can't multiply to make an irrational number. The associative property, we've studied that before in mathematics, right? But just to reiterate, the associative property means that you could take three elements, and then if you reorder the preference of how those elements multiply, you should get the same thing. Right now, -2 times 1 is prioritized. If I switch that, be -3 times -2 first, and then multiply by 1, you get the same thing either way. So the associative property of multiplication is there. So that means it's got the associative property for integers. Remember, the goal is to identify whether this is a group. So it has to satisfy all these, or else it's not a group. The identity element needs to be present. That means there needs to be an element so that you can multiply it to any other element and get that other element as a result. So that identity element, we've also studied that in math. It's 1. If you pair up any number 1 with sorry, let me say that again. If you multiply any number to the number 1, you get out that same number. The identity property is happening. Okay. And then we need to have an inverse. We need the inverse property to be true. For it to have the inverse property, every element in the set has to be able to have the operation on it so that you can get out the identity. Okay. The identity is 1. We just identified it has an identity element. So what that means is that the operation is multiplication. We should be able to take every element, multiply it by something from the set of integers, and get out 1. Okay. And there's plenty of examples where this doesn't happen. If you take -3, you can't multiply it by anything in order to get out 1, right? We know we know how to make -3 equal 1 through multiplication. It needs to be the reciprocal, but there is no -1/3 in the set of integers, so that can't happen. If you even find one example that disobeys any of these properties, then you can cancel it out. I just found one example. -3 times -1/3 equals 1. That can't be the inverse because it's not a part of the set of integers. So it does not have the inverse property. Sorry, so I stopped the video too soon. That means it's not a group. It has to obey all 4 of these for it to be a group. Since it doesn't have an inverse property, the set of integers under the operation of multiplication does not form a group.